So we're going to do a question that tackles the volume of a frustrum and also the surface area of the same frustrum, okay? So the question is something like this. We have a frustrum here, and then from this frustrum, we've been given the bottom bit as 21 centimeters, and then we've been given the top bit as 14 centimeters, okay? Let me just roll my work a bit. So we are supposed to go through the process of getting the volume of the frustrum and also get the surface area of the frustrum, right? The closed surface area of the frustrum. You know there's a difference, right? That being said, how do we tackle this? We tackle this by first of all extrapolating and imagining that this was a complete cone, okay? That gives you a perfect picture of what was there before it was cut off. So we have this bit, we have this bit, okay? Once we've checked that out, we now also imagine we will need a height, right? We will need a height from this bit. Let's say it's coming up to that point, okay? Now, once we've established that, we have been told that we have this bit being 22.5, okay? 22.5 centimeters. So we have to go further and try and find this arbitrary value which we don't know of, so that we can get the height of the full cone. Let's give it an arbitrary value of x, okay? Once we've established that, we come to a point whereby we say, okay, so this is what we have, and this is what we are looking for at the moment. We use proportions, okay? If we are very keen, you'll find that this resembles a right angle triangle at the large one, and then this resembles a small right angle triangle. So they are proportional to each other. So we can say probably the base all over the height is proportional to this one's base all over the height, okay? So I'm going to say 21 centimeters all over the height of the large one, which is 22.5 plus x, which we don't know, is equivalent to what? Is equivalent to 14, which is the small one, all over x. And so we end up doing what? We end up cross multiplying, which is going to be 21x is equals to 14 all over 22.5 plus x, okay? Now, since we've established that it's going to be 21x is equals to 14 multiplied by 22.5, that's going to give us 315 plus this is going to be 14x, okay? So let's move the 14 this other side. It's going to be 21x minus 14x is equivalent to 315. That's going to give us 7x is equivalent to 315. Let's divide this by 7. Let's divide this by 7. So it's going to give us x being 45 centimeters. Good. So we've gone ahead and found the arbitrary value of x being 45 centimeters, right? Now we get to the main formula of getting the volume of, first of all, a cone, okay? So the volume of getting a cone is usually equal to pi r squared h divided by 3, or you can also say a third pi r squared h, okay? So the pi, we know what it is. The r is usually the radius, okay? The radius of the bottom bit of the cone we are talking about. So like if it's this cone, the large cone, the bottom bit is going to be 21. radius. If it's this cutout cone, the bottom bit is going to be the what? The top bit of the frustum. Okay, good. So we start off with the volume of the large cone, which is a third pi multiplied by r, which is 21 squared, multiplied by the height, which we have determined to be 22.5 plus 45. Okay, that's going to be 67.5, right? It's going to be 67.5 multiplied by 21 squared, okay, multiplied by 22 over 7, multiplied by 22 over 7, then divide by 3, okay. That gives us 31,185 centimeters cubed. That's the value of the large cone, okay. Once we've established that, we want the volume of the small cone, which is going to be a third multiplied by pi, multiplied by now the small bit, okay, 14 squared, multiplied by its height, which is 45. Now let's see what we anticipate to get this as. Is going to be 45 multiplied by 14 squared, then multiplied by 22 over 7, then divided by 3, right? Divided by 3. That's going to give us 9240. So we get 9240 centimeters cubed as this bit, right? After we established that, so we want to get now 31,185 centimeters cubed, which is the volume of the large cone. Then we deduct 9240 centimeters cubed, which is the volume of the small cone, right? So we're going to say 31,185 minus whichever was previously that, it's going to be 21,945, right? We're going to get 21,945 centimeters cubed as the volume of the frustum, okay? So I'll just reiterate whatever we've done. First of all, you're going to be given the frustum. Extrapolate it so that you can see visually whatever it is you have. After you have that, you're going to be asked to remove the top cone and then remain with the frustum. So how do we do that? We do that by getting this arbitrary value first using proportion, and then we calculate the volume of the large cone, then we minus the volume of the small cone. Now that's a little bit easy. So let's go further and look for the surface area of the same frustum, okay? So if you're looking for the surface area of the frustum, we are going to get it as surface area is equals to pi rs, okay? Now this is surface area of a cone, okay? We first of all use the formula to get the surface area of the cone. Then from that we will go further and use it to get the surface area of the first one. So if you're going to get the surface area of a cone, it's usually pi rs, and pi rs gives you this section, okay? This section that is usually curved, okay? And then you know we have the bottom bit, right? So the bottom bit is going to be pi plus pi r squared, okay? So the surface area of a cone. But as we want what? We want the surface area of the frustum. So we are going to work with getting the surface area of the cone, which is large, then we minus the surface area of the cone, which is small. After we do that, now we'll add the two circles, okay? So we are going to do something like pi r capital S minus pi r small s. Okay, now you might be asking yourself, what is s? Sorry if I didn't explain. It's this slant bit. Okay, so we have this slant bit here. You can say it's probably the longest bit of a triangle. The slant bit, the hypotenuse, right? The slant bit here. Okay, so we are going to do what? We are going to try and find the slant bit of the large cone and the slant bit, the slant part of the small cone. Okay, let's go. We're just going to use Pythagoras theorem. They tend to say a squared plus b squared is equals to c squared. Let's take our a to be 21. Okay, so that's going to be 21 squared plus our b to be 14 squared. That's going to give us what? Let's check. 21 squared plus 14 squared. It's going to give us 637. Okay, that's because we are taking, sorry, it's not going to be 14. It's going to be 21 squared plus the height, and the height is 67.5. Is that true? Yes, 67.5 squared. I'm sorry about that mistake. 67.5 squared plus 21 squared. That gives us this value, 4997.25. Let's look for the square root of that. It's going to be 70.691. It's going to be 70.691 centimeters. Yes. So the slant bit of the large cone is that. Now we need to find the slant bit of the small cone. Okay, this is the slant bit. This is S, right? Now we look for the slant bit of the small cone, S, which is going to be what? It's going to be 14 squared plus, which was now gotten as 45 squared, right? It's going to give us, let's see, 45 squared plus 14 squared. We get that. Look for the square root of that bit. It's going to be 47.127. It's going to be 47.127 centimeters. So we have the slant bit of the large cone, we have the slant bit of the small cone. So let's remove the surface area of the small cone from the large cone. Is that true? So we're going to say pi multiplied by the large R. Let's just put it as the large R. Okay, the large R, which is 21. Okay, multiplied by the large S, which we have established to be 70.691, and then we deduct pi times the small what? The small r, which is 14, multiplied by the small s, which we have established as 47.127. So what's it going to give us? So we have 70.691 times 21, that gives us 1484.511 pi. 1484.511 pi minus, another one is going to be 47.127. 47.127 multiplied by 14. It's going to give us 659.778. Sorry, 659.778 pi. So let's do the deduction. 84.511 deducted from whatever is there. So we're left with 824.733. 824.733 pi, right? So that's now the value of the cone, the large cone minus the small cone. So we are left with the frustrum. But after that, and it's don't remember it's still in pi, we can just do multiply by 22 over 7, right? Multiply by 22 over 7. That gives us 2592. Okay, 2592.0 centimeters squared. Okay, once we have that, that's the value, surface area value of the frustum. So we need to put in the top circle and we need to put in the bottom circle also. Okay, let's do this. So we have pi r squared and we have pi r squared to be added. Okay, so it's 22/7 multiplied by 21 squared plus 22/7 multiplied by 14 squared. Okay, so what do we have here? We have 21 squared multiplied by 22 divided by 7, that gives us 1386. 1386 plus 22/7 22/7 multiply by 14 divide 22/7 multiply by 14 squared. Sorry, 22/7 multiply by 14 squared. That gives us 616. So we're going to take this and then we are going to add whatever we got here, 2592. Okay, 2592. Let's see now. 616 plus 1386, 1386 plus 2592, 2592. That gives us now 4,594 centimeters squared, because we are looking for surface area and not volume. And yeah, that's how it's done. If anybody has some question, you can send them down on the comment section, and have a good day.